This is the video answer key for unit circle trig worksheets that you're getting, the two worksheets tonight. Now, as you're working on this worksheet, make sure that you have two things that you're using to reference. Make sure that you, A, have your unit circle, and then B, the chart of trig values. Both of those are in your previous notes. I'm going to be verbally talking through how I'm making that reference. You can see in those notes how I'm actually using those charts, what I'm going through and looking at, but we want to start getting used to the idea that we can use these references without going through the process every single time. So we're just going to start breaking it down and looking. For question number 1, it's asking tan of theta, and it's giving you the theta. It's telling you that your theta is 60 degrees here. It wants the tangent value. I'm going to go to my chart, and I'm going to see on my chart I have a 60-degree angle, and that chart tells me that the tangent for a 60-degree angle is just the square root of 3. This is my answer. That's all I need to do. Number 2, I've got the sine of 225 degrees. This is a little bit more involved. This is already showing me where the angle ends up, so I know that this stops in quadrant 3. I can see that because it's right here. I'll remind you that your quadrants go 1, 2, 3, and 4. And I know that in quadrant 3, my sine is negative, and I have that from my graph, or from the notes, 6.2 part 3. In the 6.2 part 3 notes, I know that my sine is negative in quadrant 3. And then I know from my unit circle, I look at my unit circle and I see that 225 degrees is the same thing as 5 pi over 4. So that means that I'm looking at a pi over 4 angle. The magnitude for my pi over 4 angles is root 2 over 2. So my answer here is the negative square root of 2 over 2. And then I stop there. That's all I need to do. That's my answer. I'll give you another example. Let's look at, we're going to do the tangent of theta, 150 degrees. We're in quadrant 2 here. I know, quadrant 2, I apologize. We're in quadrant 2 here. We know that tangent is negative in quadrant 2. I look at my unit circle. I see 150 degrees is the same thing as 5 pi over 6. So I'm looking at a pi over 6 style of angle for my magnitude. My tangents of pi over 6s are root 3 over 3. And since I'm in quadrant 2, this is a negative root 3 over 3. That's how I go about doing those. It gets a little bit more complicated when we're here, when we're moving to 11 through 30, because now I'm actually going to have to go through the process of drawing the angles. So we're just going to start with cotangent of 7 pi over 4. I'll go ahead, I'll make a quadrant, I'll draw out what 7 pi over 4 is, and I even know from my unit circle this is where 7 pi over 4 terminates. Terminates in quadrant 4. In quadrant 4, cotangent is negative, and I know that this is a pi over 4 angle, so I need something, so I need to know what the cotangent is for pi over 4s. Cotangent for pi over 4 angles is 1, so this is a value of negative 1. I'm going to do, let's look at number 14 as well. I've got the cosecant of 2 pi over 3. I'll draw 2 pi over 3. It terminates up here. I already know this from my unit circle as well. I know exactly where 2 pi over 3 is. I see that this is quadrant 2, and I know from those notes that in quadrant 2, my cosecant is a positive value. I say to myself, all right, this is obviously a pi over 3 angle since it's 2 pi over 3. My pi over 3 angles for my cosecant, their magnitude is 2 root 3 over 3. This is a positive angle, so my answer, or a positive value, my answer is just 2 root 3 over 3. And that's how I'm going to go about doing a lot of these, is I'm going to draw out the angle and see where it terminates. It starts getting a little bit more complicated for things such as tangent of negative 13 pi over 6. What I have to realize here is that this is negative 13 pi over 6. Well, that's negative pi over 6 minus 12 pi over 6. And the reason I say that is because 12 pi over 6 is 2 pi. That's beyond a full revolution. So that means that this angle looks like this for number 21. And it terminates here. So this is a quadrant 4 angle, which means that my tangent is negative, and since my tangent is negative in quadrant 4, I have to go through the process of considering, all right, what type of angle am I looking at here? I'm looking at a pi over 6, 13 pi over 6. It's still a pi over 6 angle. I know that I'm looking at a negative tangent, and I know that for pi over 6, my tangent magnitudes are root 3 over 3, and I'm using that chart from my notes in order to get my tangent magnitudes. So this is my answer to number 21. That's how I go about doing that. If I look at the secant of 945 degrees, I have to start thinking to myself, all right, I've got 360 plus 360 is 720. Another 360 on top of this is obviously going to get me past 1,000, so I'm going to do 945 minus 720. And I realize that this is 225 degrees. I know from my unit circle 225 degrees is going to terminate in quadrant 3, but we'll draw this out. I've got 2 full revolutions, and it's going to stop here at 225 degrees past that final revolution. I know that this is going to end up corresponding with pi over 4 angles because I'm going to look at my unit circle. I see that I'm 225 degrees past a full revolution. 225 degrees corresponds to 5 pi over 4. Since it's 5 pi over 4, this is a pi over 4 style of a unit circle angle. It's 45 degrees from that x-axis. I'm looking at my secant in quadrant 3. Secant is negative. So that means that I'm looking at a negative secant value for pi over 4s, and your secant values for pi over 4s is negative root 2. So that's how I'm going to go about doing these. I'm going to go through the process of figuring out what the angle is. I'll draw the angle, find what the exact value is, and then just go from there. So it's as simple as that. It takes some time. It's a little bit tedious. It's going to take some practice. And I know that I have a lot of these tonight, but that's because it's going to do you really well. It's going to be a lot of work. By the time that you get through 5 or 6 of these, you kind of start falling into a rhythm. You really start getting the pattern down, and then it becomes quicker. You start knowing what you're referencing and how to get there. On your second worksheet, the first thing it does is it just starts asking you to find the value. So you're going to do exactly what you just finished up with on that first worksheet. I've got the cosine of negative 4 pi over 3. I'm going to go ahead. I'm going to draw out negative 4 pi over 3. I realize that it terminates up here. So this is a quadrant 2 angle. This is quadrant 2. So that means my cosine is negative. I'm still talking about a pi over 3 value. And since it's a cosine of a pi over 3, this is negative root 3 over 2. That's what my cosine value is here. When I'm talking about the sine of 330 degrees, I go ahead, I draw out 330 degrees. I can also look at my unit circle and see that this is the same thing as 11 pi over 6. I'm in quadrant 4, so that means my sine is negative, and since I'm with a pi over 6 angle, that means I'm looking at negative 1/2 as my sine for number 13. So I'm just going to go through and do that same process. This is just asking about sine and cosine over and over and over. Number 21 starts asking me to state the quadrant in which the terminal side of each angle lies. So here, asking me to draw out my angle and try to figure out where it's at. 5 pi over 6. This is on the unit circle. Based on the fact that it's in the unit circle, you should know that this is in quadrant 2. Negative 7 pi over 4. We can draw that backwards. We can see that it's going to be over here, so this is going to lie in quadrant 1. We can start doing some other estimations, so such as number 23, 13 pi over 9. Well, we know that 18 pi over 9 would be 2 pi. 9 pi over 9 would be pi. We have to break that down. 9 and half is 4.5. So 9 plus 4.5 would give me 13.5 pi over 9 to equate to 3 pi over 2. So we know that this 13 pi over 9 has to fall somewhere in here in this quadrant 3 range. So I'm going to go ahead and say that that's quadrant 3. I'm going to do the same thing over here for number 24. I see that it's negative 17 pi over 18. That's really, really close to being negative 18 pi over negative 18. I move in that direction, and I see that this is going to lie in quadrant 3. So all it's asking me for number 21 through 28 is to figure out where that angle finally ends up. Where is the terminal side of that angle? Number 29 through 34 is finding the exact trig value. I've already done this. I've already shown you an example. Here you're going to have to pay attention to where some of these revolutions are larger. This one, what is this angle in degrees? So this goes back to practicing your unit conversions here, your conversions to degrees. I go through the process of reducing this. I've got negative 13 times 45. That's 450 plus 45 times 3 is 135. So this is negative 585 degrees. I'm just going through my unit conversion there, and we're going to do that on all of these. You're multiplying by 180 over pi. Draw the entire unit circle. That's not something I'm super concerned with. I do advise doing that for practice, though. So that's how you go about this worksheet. This worksheet is only sine and cosine. Really kind of helps you get used to what that unit circle is. Gets you used to working in those x and y coordinates. The other worksheet definitely gives you all the values, makes you work on that a little bit more. And again, if you have any questions, reach out earlier rather than later, and have a great night.